Find the equation of the tangent line to the graph of h of x equals 3x squared minus 7x minus 2 when x is equal to 3. And once we do that, we're going to graph both the function h of x and the tangent line on Desmos to make sure everything visually lines up with our solution. Okay, so we're looking for the equation of the tangent line. Okay, the equation of a line is y equals mx plus b. Y equals mx plus b, and m is the slope of the tangent line, and that's what the derivative tells us. So in this case, the slope of the tangent line is equal to h prime of 3, or the derivative evaluated at 3. So we're going to use the definition of the derivative here. So we need the derivative of the h function. We need h prime of x, and that's equal to the limit as delta x goes to 0 of h of x plus delta x minus h of x all over delta x. So what I'm going to do is let's bring the h of x plus delta x. Let's figure that out first, so we don't have to keep rewriting the limit over and over. So let's switch to orange because we're doing this in orange. H of x plus delta x. We'll plug in an x plus delta x in for these x's in our h function. So that's 3 times x plus delta x squared minus 7 times x plus delta x minus 2. Okay, so we could multiply through x plus delta x times itself, or x plus delta x squared. So we'll have a 3. So that'll be x squared plus 2x times delta x plus delta x squared. Okay. Then we have a minus. We could distribute the 7. So minus 7x minus 7 delta x. And then there's a minus 2. Okay, so it looks like if we distribute now the 3, we'll have 3x squared plus 6x times delta x plus 3 delta x squared minus 7x minus 7 delta x minus 2. Okay, so now we could plug this into our definition of the derivative. Okay, so we have h prime of x, the derivative of h of x, is equal to the limit as delta x approaches 0 of h of x plus delta x. So that's this, what we came up with in orange. So 3x squared plus 6x delta x plus 3 times delta x squared minus 7x minus 7 delta x minus 2. Okay, so that's the h of x plus delta x. And now I have to subtract the original function h of x. So we're going to subtract 3x squared minus 7x minus 2. Okay, so we could simplify. There's definitely some canceling that we could do here. Limit as delta x goes to 0. So we've got, well, there's a 3x squared and a minus 3x squared. We have a minus 7x and a minus 7x, so that's a plus 7x. We have a minus 2 and a minus 2, so that's a plus 2. Okay, so what do we have? There's a 6x times delta x plus a 3 delta x squared minus 7 delta x. That's what's left on top. And then that's over delta x. Now, every term in the numerator has a delta x. So let's factor that out so we can cancel the delta x on the bottom. So h prime of x is equal to the limit as delta x goes to 0 of delta x, which we're factoring out on top. So we're left with 6x from the first term. We're left with the 3 and one of those delta x's from the middle term. And if we factor out that last delta x, there's a minus 7. So we can finally cancel off this delta x on the bottom with this factor of delta x on top. So h prime of x is equal to the limit as delta x goes to 0 of 6x plus 3 delta x minus 7. So far, there's been no calculus. It's all algebra. We're finally at a point where we could apply the limit without giving us a 0 in the denominator of a fraction. So it looks like h prime of x, the derivative of h of x, is equal to, well, when delta x is 0, that's 3 times 0, so that middle term disappears, and we have 6x minus 7. So there is our derivative. And we want the slope of the tangent line, which the derivative tells us, the slope of the tangent line, specifically when x is equal to 3. So the slope of the tangent line is equal to h prime of 3. Or, if we plug in 3 for x, 6 times 3 is 18. 18 minus 7 is 11. Okay, so we have our slope. So the equation of the tangent line, y equals mx plus b. Well, now we know it's y equals 11x plus b. So now we need b. So what we could do is we could plug in a point. We could plug in an x and a y, and then we could solve for the only remaining variable, which is b. So, question, what is the point? What is the xy point that we could plug in? Well, we know the x value is 3. So at this point, we could plug in the point 3 comma something into our equation of the tangent line. Well, we need to know what is the y value when x is equal to 3. So we need h of 3. So plug in 3 into the original h function. So that's 3 times, we'll plug in 3 for x, 3x squared minus 7x minus 2. So 3 times 3 is 9, times 3 is 27, so that's 27 minus 21 minus 2. 27 minus 21 is 6, minus 2 is 4. So we're going to plug in the point 3, 4 into this equation. Okay, and then that'll allow us to solve for b. So when y is equal to 4, x is equal to 3. So y equals mx plus b, or 4 equals 33 plus b, or b is equal to negative 29. Okay, so now we have our slope is 11, our y-intercept is 29. So the equation of the tangent line, y equals mx plus b, y equals 11x plus negative 29 or minus 29. And there is the equation of the tangent line to the graph of h of x when x is equal to 3. So what we want to do now is graph. So let's start this over. What we want to do now is graph h of x and graph the tangent line that we just found to make sure it looks the way it should look. Okay, so h of x is given, that's 3x to the second power minus 7x minus 2. Okay, so there's our function. And we have the point 3, 4. So when we graph the tangent line, it should intersect this parabola right at the point 3, 4. Ooh. So here is 3, 4. So okay, so right around here, our tangent line should intersect. If we've done this right, our tangent line should intersect the parabola. Okay, so y equals, and our tangent line was 11x minus 29. So 11x minus 29. And yeah, it looks like our tangent line is right where it should be. Looks like it's intersecting the graph right around here at the point 3, 4. Okay, looks good. So that about does it for this problem. We have our function, and as you can see, there's quite a bit of algebra involved here. And as I've said a number of times in the past, calculus is a very algebraically intensive course. Really, the only step in this entire problem that was calculus was right here. That's it. Applying the limit. Well, starting with this formula. So we're starting with a calculus formula. And all the work involved, once we choose this formula, all the work involved is all algebra. Except for this one step where we let delta x go to 0, that's applying the limit. Okay, so keep that in mind moving forward. It's very, very algebraically intensive. So your algebra skills are very important to being successful in calculus.